Yeah, and while we get the slides on, I'm just going to say a couple of words. We have Jérôme Meyer from Nokia, who's going to talk about something slightly different, about how you look at the traffic on the internet for security reasons and things, and the floor is yours, please.
Thank you. All right. So yes, my name is Jérôme. I'm a security researcher for Nokia. So first disclaimer, Nokia is a network vendor. Second disclaimer, Nokia does not do mobile phones anymore. I've gotten the question a couple of times since yesterday, so I thought I would clarify. So today I'm going to talk about methods that we can use for distributed denial of service mitigation, and particularly as we see that let's say the sources of traffic that constitute DDoS have changed over the past 24 months. So first off, just to set a bit the scene, so DDoS has been around for a while. So for the past 20 plus years, we've seen DDoS happen. A lot of it coming from spoofed sources, so from hosting providers that do not filter out on addresses that they do not own, and primarily from a limited number of hosting providers. So typically when we looked at it about 2 years ago, we presented the results at NANOG, so one of the operator forums. We saw that really the spoof traffic at the time was coming from less than 50 hosting providers. Some of them hosted in Eastern Europe, Russia, some of them in Asia. But really this is let's say, the first 20 years of DDoS. A lot of it, and still that is the case today, it's a ton of NTP and DNS amplification. So those are relatively old protocols, UDP-based, and a lot of them still now are still misconfigured and can be abused into reflecting and amplifying DDoS traffic. We still see a lot of it today in the small portion, or at least the smaller portion today that we see from spoof sources, but this has really been changing over the past 18 to 24 months. So what we've done is to look at DDoS attack samples, and I will explain a bit how we did that in a minute, to understand what were the sources, has anything changed on that, and how can we use that to better address and mitigate these sources of traffic. So first off, just to explain a little bit about how we went about that, we have a couple of things that we are doing to address DDoS. One is that we are actively scanning the internet, and we are doing that with our feed called Secure Genome. So Secure Genome is a threat intelligence feed that we are building by actively scanning every single IPv4 address, and also every active v6, since we can't programmatically scan all IPv6 address space. And we are specifically looking for indicators of compromise that can be exploited for DDoS botnets in particular, as well as amplifiers. So we are looking, for example, behind each IP address, what type of device it is. Is that an IoT device that can be compromised? What kind of services are running behind them, so that we can then keep state of all of the IP addresses and understand whether they can be sources of DDoS. The second is that we have our product called Deepfield Defender, deployed in service providers, large cloud providers as well. And actually one of our first deployments was in the US in NRN, so the Merit network. And we actually see through our customers, so our customers collectively have access to around 500 terabit per second of network traffic, so a significant portion of the internet traffic. And last, and this is of course the important part, so this data from networks is something that some of our customers are sharing in an anonymous manner, so that we can look at what sources of traffic can be generating DDoS traffic, and can share in real time those indicators of compromise for bots, for amplifiers, and this is how we are building this study in the past 2 years. So before it was all spoof sources, so for the majority of the DDoS traffic. Today what we see, and this is really something that has changed for the past 12 to 18 months, is that now, as of a few months ago, botnets generate the majority of DDoS. So this is something that is now really in terms of total bytes, this is really what's driving the growth of DDoS. Of course, because botnets can also be used to launch application layer DDoS, this would be the majority of the complex types of attacks, so the application layer, some of the protocol floods, but really this is really the vast majority of complex DDoS attacks. And very importantly, and why we are really talking about this today, is that this type of botnet DDoS can actually circumvent traditional DDoS systems that have been deployed for the past 2 decades. And if we look at the progression of this botnet DDoS traffic progression, so you can see on the right, the growth has been steady. We did see last year, let's say, abnormality during the invasion of Ukraine by Russia, where we had a lot of cross-border type of attacks from one country to the other, as well as other attacks from, let's say, other countries that were associated with the conflict. So this did create a kind of outlier in terms of the data points here, but really we see that now we are reaching the majority of the traffic. Now, looking at what are those bots? Where is it coming from? So when we look at the sources of those types of botnets that are generating DDoS traffic, what we really see is that it's a lot of IoT devices that are compromised. As I'm sure many of you know, so there are a ton of IoT devices, whether it is webcams, sensors, a lot of digital video recorders. We see some thermal imaging systems, even some medical systems connected to the internet with an open ports for some reason. And some of that is actually compromised and part of a botnet. We see, so of course, some of you also may have heard about the Mirai botnet. So a lot of that is thanks to MikroTik routers. We still see a ton of that traffic, even to this day, so sending DDoS traffic. And as we will see in a couple of slides, those types of botnets tend to attack in packs, so not all at once, but some of them share similar characteristics, whether it is a couple of webcams or DVRs, they tend to attack together. What we have also been seeing, and that has been changing for the past a year or so, is that we do see increasingly that cloud is now also a source of DDoS. We see, surprisingly, some very large established cloud providers that have VMs that are compromised and sending DDoS. And of course, the impact of a VM connected to a 10 gig connection can be greater than a webcam that has a 20 meg uplink. So it is small in absolute numbers of sources, but it can have a disproportionate impact in terms of the traffic it can generate and inflict on the target. So some numbers. What we are currently seeing in terms of numbers of bots, specifically for DDoS, because of course the DDoS bots are really a subset of the total botnet population. And we estimate that there are around 500,000 to 1 million botnet hosts for DDoS. We are tracking around 500,000 of them at the moment. If we take the aggregate capacity that those bots can send collectively, so we estimate that it is somewhere between 50 to 100 terabit per second. If they were to send all at once or all together traffic with the bandwidth that they have available. In reality, most of the attacks at most are in 1 to 2 terabit peaks. So that means that not one single botnet operator controls all of the DDoS bot population. In fact, so this is what is kind of interesting here. The majority of the attack is a couple of thousands of bots only. We rarely see more than 10,000 sources. We did see last year, during the Russian invasion of Ukraine, some likely nation-state actors using a botnet that was more than 60,000 devices. We don't see that happen every day. So it does also skew the data a little bit, but in everyday DDoS, it's really more about the 1,000 bot ranges. So what's changing? So I know that it's a bit different in consumer networks, than in NRANs, but so far a lot of the DDoS is originating from consumer and some enterprise networks. And historically, those types of networks have been really asymmetric because of the access technologies, whether it is DSL or DOCSIS. This is something where a lot of devices still today have a couple of tens of megs of upstream bandwidth. That is changing. So we have now operators, whether it is in Europe, in the US, and elsewhere, where now there is, of course, those mostly marketing-driven plans to have symmetrical bandwidth, which means, of course, that the webcam that had a 20 meg upstream bandwidth now has 10 gig, or 1 gig even. That can do a lot more damage. So today, even though the upstream bandwidth is a limiting factor, this is something that is going away that can also multiply the impact of those types of bots. Now, another interesting characteristic and something that is very different in botnet DDoS compared to what we used to see before with spoof traffic is that traditionally we always assume that we have to go to look at what's coming from outside of my network towards my subscribers or toward my users. And so for a long time, and even today for a lot of operators, the approach is I look at my external edges of the network and I look for inbound traffic. This is really not really the case anymore. So in the case, the kind of conventional thinking was that the US, for example, or even Europe, was the main target of DDoS. And it turns out that as we look at the data, the US is now officially a net exporter of DDoS. So they produce more than receive. And that's in large part due to all these IoT devices that are connected, DVRs with open ports, and that are compromised with CVs that has been around for a long time. So this, there is that, and also the fact that traditionally we have also been more looking at this type of spoof traffic, amplified traffic with traditional methods to block those types of attacks. It's becoming a lot more complex with botnet DDoS, which, if you just look at the traffic, looks like legitimate traffic. It comes from real devices that have real IP addresses with full TCP stacks, often based on Linux. So it's very hard just by looking at some of the traditional characteristics of traffic, whether that is DDoS or not. So how do we address this? And this is a bit hidden here, but a very common approach has been to look at, we build baseline, we look at, what was the traffic like for this particular destination last week? Is it more or less, close to that? And if not, let's put some rate limiting. Rate limiting has some use, but of course, it's great to, let's say, reduce attack traffic. It's also great to block legitimate traffic, because at the same time you will be addressing, good and bad traffic, you will be just lowering the volume. So what our approach is really is that it's not really about looking at, what quantity of traffic do you have for a particular destination, of what type of ratio do you have between CIN and CNAX, but really more looking at what's sending the packet, what's sending the traffic. And this is where the secure genome feed here comes into play, because we are able to correlate in real time the network telemetry with the attributes of the source. In this case, we see that we are looking at, so on the right, we're looking at what are some of the characteristics of those sources, source addresses. And then we can take decisions based on this information. So we are looking at this combination of the network traffic telemetry in real time with this big data approach that is afforded by Genome. Now, so just to take an example, this is a real attack sample, so DDoS attack sample that we saw through one of our customers. As you can see, so it's a fairly typical, although a bit large, botnet attack. Main vector was HTTP. We have some QUIC as well, which is a great vector right now for attackers. And as you can see here, so fairly typical on the higher end of the spectrum, so number of sources, peak a couple of hundred gigabit per second. So So something fairly significant. The target was actually a military organization, just for fun. And if we look at the sources, so this is where it gets interesting. So we have a couple of sources from NRANs. So just, of course, I filtered a bit here, but this is just to highlight that there are botnets coming from everywhere. It does not really spare any particular network. As long as you have IoT devices or cloud VMs that are not properly updated, secured, you may have hosts that become part of botnets. So in this case, we see that some of the sources here were part of the same NRAN here, which I masked. But this is really to highlight that this does not spare really anyone. And sources are geographically distributed. They can come from any network. Now if we look in a bit of details, and I apologize, it's a bit small here, so I will just explain a bit. So this is just looking at one particular IP address, again, based on the information we have in Secure Genome. And we can see here we have a couple of attributes that are interesting when we are trying to classify DDoS. One of them is that we have those tags, so the red label that you have here plus some of the orange ones. The red label is when we have seen that IP address in multiple recent DDoS attacks. The orange labels are indicators of possible compromise related to DDoS. So for example, we apply that when we see that the DNS server is responding to DNS-any queries. We have some indicators that are related to CVEs that can be exploited for an attacker to compromise the device to then have the device send DDoS traffic. And a bit further down, we see that we have, so what type of open ports, what's running behind the ports. In this case, we can see that on port 83, we have a web server that goes back to 2014, and that is vulnerable to a specific vulnerability, so CV from 2015, that can be exploited by an attacker. So all of that really helps to be able to classify in real time whether traffic is DDoS or legitimate. All right. So how do we really address this? So what we are doing on our side to really be able to adapt the response based on the information from the network plus Secure Genome is that we will combine the different sets of information to be able to craft a mitigation strategy that will be unique for the attack and for the destination network. So for example, what we look at is what is the attack mix, what is the multi-vector attack, what type of vectors do we have, is it a carpet bomb so that also we can adapt the strategy, what types of devices are available on the network, can we use the edge routers, for example, to instantiate filter entries to block directly the DDoS attacks, or do we have to divert to a scrubber? How can we program those devices? So that's also a big one. And also, and this is coming a bit, in terms of how we can cluster the different types of botnets. So we combine all of this information to craft a unique mitigation strategy that we can then translate into something the router will understand. So just to put it in a bit more visual way, what we are doing when crafting this strategy, and this of course happens automatically through this software, that will combine the information from Genome for all the data associated with the IP address with network telemetry, so flow sampling or packet sampling from the routers in the network. We will also combine that with real-world attack samples that our customers are sharing with us so that we can keep tuning the model and making sure that we minimize the false positive rate. And then, of course, we combine all this with a model that can then allow us to craft a strategy that will have the lowest false positive rate while minimizing also the resources that are taken on the network. So typically, when we talk about router-based mitigation, minimizing the number of filter entries that we are deploying on that router. And last point on this one, so I think it's a very important one, and I think something that is shared by this community is really that we are, a lot of vendors, and I won't name names, but a lot of the DDoS market is really about fear, uncertainty, and doubt. So we are trying to approach this in a bit of a different manner, where we want to be able to measure. So we want to be able to measure, what is the effectiveness of this mitigation strategy against a body of real-world attack samples, and only this way we're able to really be rational about, what is required to protect the networks and the users against those attacks. So we can train the model on new attacks, and we can make sure that whenever, for example, we make a change to the mitigation strategy, to the detection or mitigation rules, we can then later check that the change in mitigation rules is working at all previous real-world attacks, so that we keep the false positive and false negative, of course, rates to a low level. This requires collaboration, because of course, what is really the benefit here is that if there is an attack that happens in country A, and then when you look at the botnet, the attacker really attacks indiscriminately any country, any network. So we need to be able to share the attack details across networks. And this is how the data sharing we have with the global DDoS Alliance is really useful. All right, and to close, so again, botnet DDoS is something that is relatively new. That is something that was not really part of the DDoS landscape for the first 2 decades, or in a very small proportion. This is still the beginning in terms of volume of data that we are seeing, because even though the number of IoT devices is growing, the bandwidth to which those devices have access to is also growing faster. We do see involvement, but this is a bit more anecdotal from nation-state actors. And really, it is everyone's problem. So there are bots in every single network. We see that with compromised devices. We see that with cloud VMs. So it is something that really requires some collaboration. And we can now, with this capability that we have acquired over the past couple of years, address that in a much more effective manner than just looking at baselines and trying to minimize impacts. We can really address this a lot more accurately than we could in the past. And that's all. So thank you, and happy to take any questions.
Thanks. Well, there's a question here.
Yeah. Hi, and thank you for your talk. You were saying AI model or ML, they are as good as the data underneath. If there is no data model to train them, it can't be that good. You are saying that we need collaboration to gather that data intelligence and to build that intelligence. But then how it will work? Nokia, which is a commercial provider, we from research and education community, who owns the data? How would you clarify?
Sure. So the way that we build, so the GDTS, which is the Global DDoS Threat Alliance, so which is a program that we launched fairly recently, and this is something where our customers will be sharing anonymously data from attacks with us, so it's an opt-in program, of course. And this way, so we would be able to centralize the information so that it could benefit all the customers that are using Deepfield, essentially. So, of course, the challenge is that, especially as we talk about bots, the real or the near real-time nature is quite important because bots can evolve over time. IP addresses get reallocated, so it's important to not delay the sharing of information. But indeed, so far, it is something that we would centralize, but then make available to all our customers for this protection.
Just one question I ask maybe everyone who does lists of botnet hosts. Do you normalize for IP churn or known NAT addresses? So yeah. How long will you keep them when you will expire? Things like that.
Yeah. So we do age the DDoS bot tag that we have, so the label, the red label that you saw earlier. So we do age it out, so over time. So I think, if I remember correctly, right now it's about 7 days because that's typically what we assume is that it will churn through. And the more we can automate the sharing of information so that we can have more regular sampling, so of course we can even reduce it further. Because right now there has been a bit of manual process, and as we automate the process of collection of this anonymized data, then we can just edit out after a couple of days or even less than that, because we will have more occurrences where we see the bot being involved in different attacks.
With the data you collect, do you have insight into some of the manufacturers of the particular IoT devices? I know there's legislation in place that's supposed to improve the security, but some manufacturers wouldn't be as responsible or responsive as others.
Yep. Yeah. So it depends. I mean, for most devices, yes, because very often what happens is that there will be an open port, there will be a web server, and you can see from the banner which vendor it is, or from the TLS certificate you can see the common name and then the vendor type. So it is possible to get for most devices the vendor type, and we do see that let's say there are a lot of vendors that you have never heard about before, and that are some of them are still in business, some of them are not. But it is definitely something that we are keeping track of, because it is indeed something where we do see some common characteristics across bots.
Okay, thanks very much.
Thank you.